All right, this is a study guide for exam 4. And I'm just going to work each answer and you can follow along. I would, as usual, suggest that you work on it first, and then if you get stuck, look at how I did it. So first one, we're just using the product rule for exponents. C times c to the 7th times c to the 5th. The product rule says that anytime you're multiplying the same base raised to an exponent, you can keep the base the same and hold on one second. Sorry, I know I'm always readjusting that. It's like a crane where it's like a very light base and then I stick it out really far, the camera. And so if I don't weigh down the base, it loses focus faster. Keep the base the same and add the exponent. So in this case, the base is c. This exponent is an understood 1. It's not a 0. So we're adding 1 and 7 and 5. 1 and 7 and 8. 8 and 5 is 13. So this is just going to be c to the 13th. Okay. Here, we're simplifying the expression. We're also multiplying. So when you're multiplying, you want to multiply the numbers. So that's -3 times a 10. And that's -30 because the 30 was negative, the 10 was positive. X to the 7th times x to the 4th just means x to the 7 plus 4th power. And then y to the 5th plus 6th power, right? Because we're multiplying those. So we're going to add the exponent. So that becomes -30 x to the 11th. And then y to the 11th, right? Okay, that negative, it goes with all of this, but you just pick one to send it with. So we're calling it a -3. You could also call it a -x and a +3, or a -y and a +x and a +3. It doesn't matter where you put the negative, just that there's one negative for this term. There are no negatives for this term. So one negative times a positive is always going to give you a negative as your answer. 10 to the 0 power plus 10 to the 0 power. Remember that anything, and you can check this with your calculator, anything to the 0 power is 1. Even if it's x to the 0 power, no matter what x is, you're raising it to the 0 power, so it's always going to be 1. So 10 to the 0 is 1, and 10 to the 0 is 1. 10 raised to the power of 0 plus 10 raised to the power of 0 is actually 2, because that's 1 plus 1. Kind of a trick. Good. All right. Here, instead of the product rule, we're using the quotient rule for exponents. Just like here, up here, we multiplied the -3 and the +10, and we got -30. You multiply your numbers separately. So in this case, we're doing +24 divided by +21. Okay. 24 divided by 21. You're just looking for a common, you can't take 24 and divided by 21, right? It doesn't give you a whole number as an answer, but I think you can take 24 and divide it by 3, right? And you can take 21 and divide it by 3, and you get whole numbers that way. So just take the greatest common denominator and a factor that you can, or sorry, the greatest common factor. The biggest number you can divide both of them by. 24 divided by 3 we saw was 8. And then 21 divided by 3 is 7. So 24 21st is 8/7. You can check that on your calculator. 24 over 21. I know we just did it, but I'll type it in again. And 8/7 should give you the exact same decimal in your calculator. But we want to leave it in decimal form. Don't worry about 1.412. That's just to check it. Good. So you can do your numbers separately. And then we have x to the 5th, right? Divided by x, and there's no exponent attached to that x, so it's just x to the 1st. And remember, the quotient rule says if you're dividing them, you subtract. So you keep the same base and you subtract. So now it's 5 minus 1, so that's x to the 4th. So x to the 5th divided by x is x to the 4th. Another way to look at it is there are 5 x's up here. That's what x to the 5th means. There's 1 x down here. We're going to cancel them. And what we're left with is 4 x's on top and just the number 1 on the bottom. Anything divided by 1 is itself. So x to the fifth over x to the first is just x to the fourth. It always stays on top. Okay, that never goes down here unless it was down here. Okay, unless this number was the bigger number. But here, the 5 was bigger than the 1 as exponent, so it stays up with the 8, or it can go out next to that. Okay. I could explain that further, but we don't want this video to be 100 hours. Y to the 6 divided by y2, or sorry, y squared, is y to the power of 6 minus 2, which is 6 minus 2 is 4. So we have y to the fourth. Again, it goes up with the 8. Okay, so there are two different ways to write this. You can call it 8/7, and then let me write it differently. 8/7, and then right between the 8 and the 7, you can write the x to the fourth, y to the, or sorry, x to the fourth, y to the fourth. Good. Or 8/7, and then you can say 8x to the fourth, y to the fourth over 7. Those mean the same thing. So it can be out to the side, right in the middle, or it can be on top with the 8. Here we have p to the negative 8 over q to the negative 7th. Darn it. When I made the exam, I wanted those to be the same letter, and I thought they were, but now that I look at them, they're not. Okay. So we want to use positive exponents. P to the negative 8th is not positive, right? So if I want it to be positive, I'm going to move it across the fraction bar. Now we have q to the negative 7th, p to the positive 8th, so that's positive. Q to the negative 7th, we need to move it up here so that it's positive. So we have q to the 7th divided by p to the 8th. I apologize again. I think on the exam, it's going to be more like p, let's use a different letter because that's confusing. R to the negative 3rd over r to the negative 4th. Okay. Now you're going to do the same thing. You're going to move it up. So this will be r to the positive 4th, r to the positive 3rd, but you're now going to want to subtract. So r to the 4th minus 3 is just r. Okay. Another example. R to the negative 6th over r to the negative 2. Okay. That's now r squared over r to the 6th. When this number is bigger, that means there are 6 down here and 2 up here. That means you're going to have 4 left over, but it's a negative 4. So it's 1 over r to the 4th. Okay. Important. We'll have an example of it right here. So 2x to the negative 9th, x to the 6th. You can combine these. These are the same. X to the negative 9th and x to the 6th. That's the same base raised to powers. So the product rule for exponents means that we can take that same base and say negative 9 plus 6, right? The 2 remains up here. X, negative 9 plus 6 is just negative 3. And down here we have x to the negative 3 as well. If I want these to be positive, I'm going to switch them. So that becomes 2 over x to the negative 3rd, x to the positive 3rd, because I moved that, right? And then remove this one. Becomes 2x to the positive 3, x to the positive 3. Now you need to subtract, right? Because we have 3x on top, 3x on bottom. We get 2 x to the 3rd minus 3, which is just 2. 3 minus 3 is 0. X to the power of 0, remember, is 1. 2 times 1 is just 2. That wasn't a great example either. I wanted to make it clear, even if you don't watch this video, what to do if you have a bigger exponent on the bottom. That means you leave a 1 up here and an exponent on the bottom. Okay. Number 7. Z to the, yay, I found one, okay. Z to the 13th over Z to the 18th. Keep the base, subtract the exponents. 13 minus 18 is 5, right? But it's a negative 5. 13 minus 18 is a negative 5. I can't use negative exponents. So it's Z to the negative 5th There's no fraction bar, right? But I can create one. If I made a fraction bar, this is on the top, right? Because anything divided by 1 is itself. 7 divided by 1 is 7. 900 divided by 1 is still 900, right? So, but if I put it on top, that wouldn't be the same, right? So anytime you're turning something into a fraction, you're putting the 1 down here. It can't be a negative exponent, so I'm going to move it from above that fraction bar to below it. So now it's z to the positive 5th. There's nothing up here. Remember, though, that if there's nothing on the other side, you can just put a 1. Good? Okay, so z to the 13th divided by z to the 18th is 1 over z to the 5th. Another way to visualize it is there are 13 x's up here. There are 18 down here. And then you're just crossing them off. You're left with 5 on the bottom. Okay. Moving on to scientific notation. All right. So you're going to practice moving it from scientific notation to a long number without exponents. And then when it's the longer number, you're going to move it into scientific notation. Okay. So the rule is, between my holding the paper crooked and my crooked camera, it's getting bad. Okay, so the rule is you are going to change 18 million to 1.8. Okay, 1.802 in fact, right? And the rest are zeros, so you don't need to include those. But what we want is one number in front of the decimal point instead of 1, 2, 3, 4, 5, 6, 7, 8 numbers in front of the decimal point. Okay, so what you want to do is you want to determine where your decimal point is right now and how many places, how many units you have to move it to get to 1.802. Okay, 1, 2, 3, 4, 5, 6, 7. We moved it left, right? I'm very bad at that. We moved it left 7 units. Okay, so that means it's going to be 10 raised to the 7th power, and then you have to decide whether left means that's a positive 7 or a negative 7. I have 1.8, and I'm going to multiply it by 10 to the 7th or 10 to the negative 7th. You can also use your calculator. Don't be afraid. 1.802 times 10 to the negative 7th. You can try it. It might just give you a decimal because it's too big. 1.802 times 10 to the 7th. Okay, and you can check both ways and say which one looks like this. And that's a fine way to do it, okay? Or you can say that left is positive. Okay, if I had to move my decimal point left, that's going to be multiplied by a 10 to a positive exponent. Good. And then here we have the opposite. So we have 0.00038. I know that the number I want is 3.8 because I want one number in front of the decimal point. Okay, so the decimal point's right here. I'm going to count. I'm moving it 1, 2, 3, 4. Let me make sure. 1, 2, 3, 4 times 10 to the 4th. Here I'm moving it right 4 places, right, think, negative. This only works when you are doing the counting, right? And you're changing it from the number into scientific notation. Then we have to do the opposite, right? So 9.8 times 10 to the 6 means I move that decimal point right because it's positive. So 9.8, and then it's going to become a bigger number, right? Just like this becomes a bigger number 6 times. So we're going to go 1, 2, 3, 4. Okay, see, I get so confused. 1, 2, 3, 4. 5, 6. 1, 2, 3, 4, 5, 6. So that becomes 9, 8, 0, 0, 0, 0, 0. It might even be more helpful to add more colors, right? Like that's a blue, red, to keep better track. It becomes 9,800,000. Good. 9.8 times 10, sorry, to the 6. 5 zeros behind the 8. 5 zeros behind the 8. Nothing wrong with doing it like that. All right. 10 to the negative 7th, you're going to do this exact thing, but the other direction, right? So we have 6.02. Don't leave off the 0, 2, even though we're going to be moving this way. Okay. So 7 times. Here's 1. Different color. 2. 3. 4. 5. 6. 7. Okay, so here's where your decimal point is, but you want that just like up here in this example, you want a 0 in front of the decimal point. So you're going to say it's 0.000000602. Okay, 0.000000602 is equal to 6.02 times 10 to the negative 7th. Let's count. 1, 2, 3, 4, 5, 6, 7. If I move 7 to the right, I will be at 6.02. Feel good about that. Okay. This, we are now using the, well, the other one was the product rule, and then we had the quotient rule. Now we are raising a power to another power. Okay, so just take that 4 and distribute it to the 3, the x to the 8th, and the y to the 8th. If there's no parentheses, it only goes with the y to the 8th, okay? But there are parentheses, so it goes to everything in the parentheses. So that means it's 3 to the 4th, x to the 8th, to the 4th, and y to the 8th, to the 4th, okay? 3 to the 4th, I can just put it in my calculator. Or 3 4 times, right? 3 times itself, 4 times, which is 81. 8, sorry, x to the 8th to the 4th means, since that power is being raised to a power, we take the 8 and we multiply it by 4, okay? The power rule for exponents. 8 times 4 is 32. That's all you can say, is it's x to the 32nd power, because we don't know what x is, so we have to leave it as x to the 32. And then same thing with y, so you can kind of just assume that it's going to be the same number. 8 raised to the 4th power, so it's y to the power of 8 times 4, which is y to the 32nd. So what you get as your final answer is 81 x to the 32nd, y to the 32nd. Good. Here we're distributing a 2 instead of a 4. So we have 4 to the 2nd, x to the 2nd raised to the 2nd, and then x to the 6th raised to the 2nd. So I just distributed that 2. 4 squared is 4 times 4, which is 16. X squared is x to the power of 2 times 2. X to the 6th raised to the 2nd is 6 times 2. So that'll be 16 x to the 4th over x to the 12th, right? And then we're just going to subtract x to the 4th minus x, or sorry, We're going to keep the 16. If we are dividing x to the 4th power by x to the 12th power, what we can do is say it is 4 minus 12 according to the quotient rule, right? So that means it is still 16, but now it's going to be 4 minus 12 is a negative 8. Remember what we did up here when we got a negative exponent is we moved it to the bottom of the fraction bar. So you're going to have 16 on the top and you're going to have x to the 8th on the bottom. It's your final answer. We have it in, that's the simplest form we can put it in, okay? A to the negative 5th to the 2nd just means we're going to take that negative 5 and we're going to multiply it by 2 and we get a to the negative 10th. We need to move it across the fraction bar, so it's going to be 1 over a to the 10th. Just like this was, this 8 moved, this x to the negative 8th moved to the bottom. We're going to move this to the bottom, but there's no 16 on top, so you just have to put a 1 on top to hold it in place. Number 15 is very similar, but instead of a variable, we have a whole number. So we have 4 to the negative 1 raised to the 2nd power. So that's going to be negative 1 times 2. Negative 1 times a positive 2 is just a negative 2. So 4 to the power of negative 2 before you decide that that's 16, move it down here. So it's actually 1 over 4 squared, 1 over 16. Okay. You're welcome to put it in your calculator however you want. 4 to the power of negative 1, power of 2, or call it 4 to the power of negative 2, or call it 1 over 16. You should get the same answer, okay? Is this a monomial, a binomial, a trinomial, or none of these? Remember, and then the degree. So remember, this means how many terms. A term is separated by a plus or minus sign. So we have 1 term, 2 terms, 3 terms. Tri, like tricycle or triangle, means 3. The prefix tri means 3. And then the degree is the largest exponent. The largest exponent is a 2. Okay. Here we're subtracting, so you're just combining like terms, but the first thing you want to do is distribute that negative sign because it's subtraction, okay? So the first terms stay the same, 4y squared minus 5y plus 3. And then I'm going to say minus 5y squared plus 5y minus 2, because a negative times a positive is a negative times a negative becomes a positive, and then a negative times a positive becomes a negative. Now you just combine those. 4y squared minus 5y squared is a negative y squared. Negative 5y plus 5y cancel themselves out. And then plus 3 minus 2 is just plus 1. Okay, it says do not factor, so you're done. That's the simplest form. Here they're adding a bit of English into the math. So we're going to subtract 7x plus 4 from the sum of 9x squared plus 7x plus 7 and 4x squared plus 8x minus 2. Okay. Subtract this from the sum of, so I'm going to put those together first. The sum of 9x squared and 7x and 7. The sum means we're adding it. 4x squared plus 8x minus 2. Good. Now we're just combining like terms. So 9x squared and 4x squared is 13x squared. Good. Positive 7x and a positive 8x is 15x. And then 7 and negative 2 is a 5, right? So that all becomes 5. That's the sum of those two. And then we're going to subtract this from it, okay? But we're subtracting the whole thing, so make sure you put it in parentheses. Good? Okay. That's what I would do wrong in this case. 13x squared plus 15x plus 5, distribute that negative, minus 7x minus 4. Good? All right. Leave the 13x squared as it is. 15x minus 7. So 15 minus 7 is 8, right? Just like up here, 7 and 8 was 15. Now we're going to subtract the 7 again, and we get 8. I'm sorry. And then we are adding 5 minus 4, so that's just going to be 1. 13x squared plus 8x plus 1. Good. All right, there's something on there. Here, you're just going to multiply. Negative 5x times x squared becomes negative 5x to the third, right? Because we're using the rule combining exponents by multiplying. So you're just adding x to the first, and x squared becomes x to the third. Negative 5x times a positive 2x becomes a negative 10. X times x becomes x squared. And then finally, we have negative 5x times a negative 7. Negative times a negative becomes a positive. 7 times 5 is 35. And then we have an x. Okay. Simplify just means combine your like terms. We wouldn't factor this out again, or else we'd have this again. Use the FOIL method to find the product. So now we're just practicing multiplication. V times V is V squared. That's our first. Outside would be negative 8V, right? Because that's V times negative 8. Inside is going to be positive 10 times V is 10V. And then last we have a positive 10 times a negative 8. So it's a negative 80. We can simplify that a little bit by combining those two middle terms. V squared plus 2V minus 80 is what I get. Good. Great. Here we have x minus 11 times x squared plus 4x minus 9. It's the same as FOIL, except you have a middle term. So you're going to be doing x times x squared, x times 4x, x times negative 9. Then you're going to come back and do negative 11 times x squared, negative 11 times 4x, and negative 11 times negative 9. So let's see what that would look like. X times x squared is going to be x to the third, right? X times a 4x is going to be a 4. X times x is x squared. And then x times a negative 9 is just going to be negative 9x. Good. So those are my x's. 11 is a negative 11. So negative 11 times x squared is a negative 11x squared. Negative 11 times a positive 4. Think about what 4 times 10 is. It's 40, right? 4 times 11 is just going to be 40 plus 4, or 44. So positive times a negative, so it's negative 44. There's an x. So we're keeping an x. And then negative 11 times a negative 9. Again, 9 times 11. It's just that number twice. If it's single digits, negative times a negative is a positive. So 11 times 9, negative 11 times a negative 9 is going to be a positive 99, no variable. Good. All right. X to the third. 4x squared minus 11x squared. So what's 4 minus 11? That's the same as 11 minus 4, but it'll be a negative, right? 4 minus 11 is going to be a negative 7. X squared, right? So I got that one. I got those two. Negative 9 minus 44, you're just adding. 44 and 9 is 53, but negative 44 minus 9 is negative 53. Good. So minus 53x and then plus 99. And you can just mark them so that you know you've used them all. Accounted for them all, right? And then see if you have that answer choice. Call it B. Good. All right. So now I think we are moving on to, well, almost factoring. So 23 through 35 is factoring and finding the answer to the value of x in a polynomial. And there's not that many on the exam, but they're worth more on this exam, okay? So make sure you are comfortable with factoring. It's going to be very important in college algebra. Multiply using a special products method. What I want you to know here is that this does not mean 2x squared minus y squared, right? It means 2x minus y times 2x minus y, right? 2x times 2x, now you're just FOILing. 2x times 2x is 4x squared. 2x times a negative y is a negative 2xy. Negative y times 2x is another negative 2xy. And then negative y times a negative y is a positive y squared. There are faster ways to do it, but that is a reliable way to do it. So we have 4x squared minus 4xy plus y squared as our answer. Okay, the faster way that I alluded to was to use our formulas. One second. And that rule is the perfect square trinomials, factoring a perfect square trinomial. And that rule is a squared plus 2ab plus b squared is going to equal a plus b squared, and then a squared minus 2ab, that's the difference, plus b squared is going to equal a minus b squared. Oh, I'm sorry, you couldn't even see it. So if you already have, this 2x minus y squared, you can say that the first number is going to be 2x squared. The second number is going to be a negative 2 times 2x times y. And then the third number is going to be y squared, positive y squared. Okay, so you can do it this way, or you can do it this way. It does not matter, except I need to keep that one in the frame. All right, this one on the exam, it's going to say factor the polynomial completely. But what you need to know is that you are going to be factoring out the greatest common factor, and that is all you will be doing, okay? So here it's 24a to the 6th, b to the 6th, negative 21a to the 5th, b to the 5th, positive 21ab, and 6a to the 5th, b. Look at all of these and try to determine the smallest variable, right? So we're going to divide it all by a, because it's just a to the first b. So the greatest variable you can have is a to the first power, b to the first power. 24, 21, 21, and 6, you can divide them all by 3, right? So the greatest common factor of all of this is 3ab. So I'll put 3ab. 24 divided by 3 is 8, right? A to the 6th divided by a is a to the 5th. B to the 6th divided by b is b to the 6th. Sorry, 5th. Negative 21 divided by a positive 3 is a negative 7. A to the 5th becomes a to the 4th. B to the 5th becomes b to the 4th. Positive 21 divided by 3 is now 7. Again, here it was a negative 7. Here it's positive 7. A and b both cancel out, so it's just plus 7. And then plus, because it's positive, 6 divided by 3 is 2. A to the 5th becomes a to the 4th. And that is as far as you can factor it. We factored out 1a and 1b. There's nothing common to everything inside of here anymore, right? Here, what was common to it was a 3, an a, and a b. I can divide all of it by all 3 of those. So if you factor out the greatest common factor, you're left with 3ab, which is the greatest common factor. And then you have left over 8a to the 5th, b to the 5th, negative 7a to the 4th, b to the 4th, positive 7, positive 2a to the 4th. Close the parentheses. Good? All right. Now factoring by grouping. Remember when you're factoring by grouping to cover up half the polynomial, okay? Because you have 4 terms, cover up half of it. 3xy minus 4x. 3xy minus 4x, I can factor out an x, okay? 3xy minus 4x divided by x becomes x times 3y minus 4. Okay. I know this isn't the perfect venue to do it, but I feel like we've done it enough times that it should be. Okay, you're kind of just checking your answers at this point, right? Because this is a negative, we're going to make it a negative number right here. 6y and 8, you can divide them both by 2, so it's going to be a negative 2. Good. Negative 6y divided by negative 2 is a positive 3y. Positive 8 divided by negative 2 is a negative 4. Now, I have a common factor, 3y minus 4 and 3y minus 4. That means I factor out the 3y minus 4, and what I'm left with is x minus 2. Okay, done. Factor the trinomial or state that it's prime. Prime, remember, means that I cannot factor it. There are no whole numbers where I can multiply to equal c and add to equal b. That's what we're doing. At this point, I need to use different paper. Not enough space. All right, first one is y squared minus 12y plus 35. Good. I want to multiply to equal a times c is what we call it, and add to equal b. Remember, this is a, b, and c, right? Keep the signs the same. So a and c in this case is just c unless a is a number, right? So we need to multiply a number that multiplies to equal a positive 35 and adds to equal not 12, but a negative 12. Okay, then I'm just going to start listing my factors of 35, but only the negative factors because I need those two numbers to add up to a negative 12. One second, I'm losing my voice. All right, 35. We could say negative 1 and negative 35, right? I can't take 35 and divide it by 2. I can't take it and divide it by 3. I can take it and divide it by 5, right? 35 divided by 5 is going to be 7. So negative 5 times a negative 7 is going to add to 35. Is negative 5 and negative 7 equal to negative 12? Negative 5 plus negative 7 equals negative 12. It is, so that's good, right? That means y squared minus 12y plus 35 is, because a is just 1, we take those straight to x minus 5, x minus 7, and you're done. So, or sorry, y. Yikes, good thing it's multiple choice, right? I would have gotten that wrong. Y squared minus 12y plus 35 is y minus 5 times y minus 7. Y minus 5 times y minus 7. Remember, you can check your answer, okay? Refoil it out. Positive y times positive y becomes y squared. Y times a negative 7 is a negative 7y. Negative 5 times y is a negative 5y. Negative 5 times a negative 7 is a positive 35. These two, negative 7 and a negative 5, become a negative 12y. Everything else stays the same. Good. Y squared minus 12y plus 35. Back to our original. All right. So you're just factoring it. Okay. You're not saying that y equals 5 and y equals 7. You're just putting it in factored form. That's important. Okay. Maybe the last two problems we will solve for y or solve for the variable, but don't worry about that right now. Okay. Here is a very different trinomial where a is not equal to 1 anymore, right? Now a is 5 and c is 5, interestingly. So we have 5c squared plus 26c plus 5. So we want two terms that multiply to equal, well, first of all, make sure you can't factor anything out, but that's a 5, a 26, and a 5. If this was a 25, we just factor out the 5. It'd be a little bit faster, right? But we can't. So it needs to multiply to equal a times c, which is 5 times 5, they're both positive, which is 25, right? And it needs to add to equal a positive 26. So you can just start listing the factors of 25, all positive, right? So we can say it's 1 and 25. Oh my goodness, yay. 1 plus 25 is 26. So I'm going to call this, remember, because this is not 1, I cannot say that this is C plus 1, C plus 25. I cannot, okay? Because if I did that, C times C is C squared. C times 25 is 25C. C times 1 is 1C. And 25 times 1 is 25. So that just becomes C squared plus 26C plus 25, which is not, I apologize, which is not what I have up here, okay? So because it wasn't that A is 1, right? A is 5, we have to write them as group. We're grouping it now. So we're going to call this C and 25C. So 26C becomes 1C and 25C. Okay, so we're kind of doing a backwards factoring by grouping, right? To solve this one, right? We said y times y is y squared, y times -7 is -7y, -5 times y is a -5y, 5 times 7 is 35, and then we put it to -12y, right? Now we're going backwards. Yeah, so now we have 5c squared plus c plus 25c plus 5, and now we're going to factor by grouping. 5c squared plus c, the only thing I can factor out of that is a c, so I get c times 5c plus 1 plus 25c, so that's a positive, and we're going to call this 5, right? So plus 5, 25c divided by 5 is just 5c, 5 divided by 5 is just a 1. What I have in common with both is 5c plus 1. And then when I factor those out, I get c plus 5. Now, if I check this, I should get this answer, okay? So my answer here is 5c plus 1, c plus 5, or c plus 5, 5c plus 1. The order does not matter, you're just multiplying, okay? 27 asks us to factor the polynomial 4x squared minus 11x plus 7 by grouping. It's by grouping because, again, the a is not a 1. So we need to multiply to equal 4 times 7 because that's a times c. Sorry, 4 times 7 is 28. And it needs to add to equal -11, okay? So if it's going to multiply to a positive but add to a negative, I only want the negative factors. So -1, -28. What's 28 divided by a -2? It's going to be a -14, right? What is 28 divided by a -3? That's not going to work, right? 28 divided by a -4 is going to be a -7, just like it was here. 4 times 7 is 28. So -4, oops, sorry. -4 and -7 is also going to be 28. But -4 and -7 also add to -11. So factoring by grouping, we can change it to 4x squared. Instead of -11, we're going to say minus 4x minus 7x plus 7. Good. So that's my grouping. I got these two as numbers I can multiply to equal a times c and numbers I can add to equal b. Good. Factoring by grouping means look at the first two numbers, two terms, 4x squared minus 4x. I can divide them both by 4x, right? So 4x squared divided by 4x just leaves me with an x. -4x divided by 4x just leaves me with a -1. Here I have -7x plus 7 because of that minus right there. I know this number has to be a negative, so I'm going to put a minus here. 7x and 7, the only thing that's common to both is 7. -7x divided by -7 leaves me with an x. +7 divided by -7 leaves me with a -1. I have x minus 1 common to both, and so my final answer, when I factor out the x minus 1, is x minus 1 times 4x minus 7. That's about right. Good. All right, a few more of these. Factor completely 4x squared minus 8x plus 4. So what I would do here is I would say it needs to multiply to equal a times c, which is 4 times 4, which is 16, and it needs to add to equal a negative 8. So let's think about that. The factors of 16 that would become negative 8 if I added them, it's not negative 1 and negative 16, right? But is it negative 4 and negative 4? Yes, right? Negative 4 plus negative 4 is negative 8. So 4x squared, instead of negative 8x, I'm going to say minus 4x plus 4. Good. Now, 4x squared minus 4x, I can divide it all by a 4x. So it's going to be 4x. 4x squared divided by 4x is just x. Negative 4x divided by 4x is a negative 1. Here we have a negative 4x plus 4, so I know this has to be a negative. So it's going to put a minus here. Negative 4x and a positive 4, I'm going to divide out a 4. And negative 4x divided by 4 is just a positive x, because negative divided by negative is a positive 1. Positive 4 divided by negative 4 is a negative 1. Okay, what I get in the end is that x minus 1 factored out being multiplied by 4x minus 4. Good. All right, again, w squared plus 10w plus 25. We are back to a is 1, so it'll be a little bit easier. So it just needs to multiply to equal 25, add, sorry, add to equal 10. Ooh, I like 5 and 5, right? 5 times 5 is 10, and 5 times 5 is 25. So I'm going to call it x plus 5 times x plus 5. Very important. That looks like this. Okay. Here we have 7y squared minus 35y plus 28. Then y squared minus 35y plus 28. I need two numbers that will multiply to give me 28 times 7. 196. And add to give me negative 35. But wait, these numbers are very big, right? 7, 35, and 28. Can I divide them by anything? Let's first see if I can't divide them all by 7, right? So 7y squared divided by 7 is just y squared. Negative 35y divided by 7 is a negative 5y. Positive 28 divided by 7 is 4. So I can call this 7 times y squared plus 5y plus 4. So now instead of these big numbers, I have, I'm just going to keep the 7 on the outside. It needs to multiply to equal 4, add to equal negative 5. So now my number is negative 1 and negative 4, right? Negative 1 and negative 4 become negative 5 if I add them, and they multiply to equal positive 4. So now it is y minus 1 times y minus 4 times 7. Okay, so always make sure that I can't take all three of those numbers and divide them by a common denominator. Again, you can go back and make sure that this all multiplies out. 7 times y is 7y. 7 times 1 is a negative 7. 7 times y, 7y times 7 times y is 7y squared. 7y times a negative 4 is a negative 28y. Negative 7y. And then negative 7 times a negative 4 is a positive 28. 7y squared minus 35y plus 28. So that will still work out to the number you had at the beginning. So keep the 7 out in front, and then it's y minus 1 times y minus 4. Good. All right. Factor the binomial completely. 5x to the 25th minus 81. Here you have the difference of two squares, okay? Remember that the rule for the difference of two squares is a squared minus b squared equals a plus b multiplied by the quantity a minus b, okay? So you want to find out what a is. A is 5x in this case, right? And b is 9. I almost called it 8 because 25x squared is 5x and not the negative 81 because that's right here. The 81, the square root of 81 is 9. So we're going to call this 5x plus 9 times 5x minus 9. And if you go through and FOIL it, you will get back to 25x squared minus 81. Good. All right. These last 4. The last 4, you are finding the value of x, okay? So because, and the difference is that it's equal to 0. All of these have nothing equal to 0, so you don't need to find x, okay? If it says equal to 0, that means you're going to say the solution set is, what is x? If it's already been factored for you, you just take that factor pair. X plus 6 is 0. That means x is negative 6, right? 3x minus 5 is 0. That means 3x is a positive 5. X is 5/3, right? So my solution set is 5/3, comma 6. So negative 6, I apologize. Okay, and what I had, the way I did that was I subtracted 6, right? I added 5, I divided by 3. Okay, I don't want to go too fast. Solve the equation. Again, it's set equal to 0. So you're not going to take that 9x times x, 9x times negative 4. What you're going to say is this side is equal to 0 and this side is equal to 0. Okay, divide by 9, x is 0, add 4, x is 4. So the solution set is 0, 4. Okay. My last two examples, you're going to have to first factor it and then find what t is. So we have t squared plus 9t plus 20 equals 0. That means I want to find t, okay, because I have it equal to 0. It needs to multiply to equal 20, and it needs to add to equal a positive 9. What are the factors of 20? 1 and 20, 2 and 10, 4 and 5, right? 4 plus 5 is 9. So we're going to say that that is t plus 4 times t plus 5 equals 0, right? That means I can say t plus 4 is 0 and t plus 5 is 0. That means t is negative 4, t is negative 5. Good. Negative 5, negative 4. Last one. X squared minus 6x equals 27. Step 1, set it equal to 0. Okay, so to subtract 27, I get x squared minus 6x minus 27 is 0. Good. Multiply to equal negative 27, add to equal negative 6. What are the factors of 27? I'm not good at this. We want the bigger number to be negative. So I'm going to say positive 1, negative 27, right? 27, I can't divide it by 2 because it's not even. 27 divided by 3 is 9. So I can call it negative 9, positive 3, right? Negative 9 plus 3 is negative 6. Negative 9 times 3 is negative 27. So I'm going to say that this is x plus 3 times x minus 9 equals 0. That means x plus 3 is 0. X is negative 3. X minus 9 is 0. X is a positive 9. So the solution set is -3, and 9. Definitely email me if you have any questions about any of the problems we did in this review. Thanks, guys.